Right. So how many teams are there from Pera? Okay. Moratuwa? KDU? Any other teams? The last time we have had a couple of teams from NSPM and another private university. I don't know why didn't they turn up this time. Right, I'm Dhananjay Karunaratne, as you all have heard. I worked for Sri Lanka Air Force for 16 years, and then I part-time lecturing at KDU and doing many other stuff. That's about me. So I want to give you a little introduction of what you are supposed to do and what you are going to do, right? So what is this? Somebody can get me that again. Now this height is not enough for me to, fly that properly. Now what is it? Thank you. What is it? No, it doesn't have an elevation. Anyway, now what is this? Yellow. Huh? You call it a paper plane, right? Now why do you think this can fly? There's a team from KDU, those who are fourth year undergrads. I don't expect an answer from them. I know what's their level of knowledge also. So you guys have to compete them, and we'll see how far they have learned and how effective is our teaching also, right? In a way. Right, why do you think this can fly? What is flying? What is flying? You should be able to make yourself into the sky, isn't it? You yourself, or with the assistance of another machine, you should be able to get into the sky and sustain there. That is flying, simply. So what is the basic obstacle for this? What is the basic obstacle that is against this will to fly? Huh? Weight. Okay. Yes, weight, gravity, whatever it is, coping of time, space, or whatever it is, it's your weight, right? So against weight, what you are supposed to do is generate an upward force. You need that. So how is it done? I hope you all are learning in English medium, right? Don't be so dumb, huh? I mean, not be dumb, right? Don't express that you're dumb. What is this? Negative, everybody. Hurry up. Good morning. Good morning. Right. Let's go with this now. Any airplane, any sort of airplane operating on Earth, they have to produce an upward force. Right? They have to produce an upward force. We call that lift. But when you take an airplane, it's not only the weight and the lift. What are the other forces acting on it? So have you seen any airplane that could climb up like this? What about helicopters? They do, right? They do. But it's rotary wing. I'm asking about fixed wing. These are fixed wings. Wings are fixed. In birds, are the wings fixed? Yes, the wings are fixed, but at the same time they are flexible. They can move. But the wings are fixed onto the body of the bird, right? So same way, since it's coming from birds, I think people have produced this fixed wing aircraft first. Anyway, no. Just keep the helicopters, rotary wing aircraft aside for a moment and think, there's no machine that could climb up in the sky like this. Yes, there are VTOL aircraft, vertical takeoff and landing aircraft are there, modern technology. But to go up like this, you need to move forward also, right? Without moving forward, without moving through the air, you cannot produce what you call as lift. So to produce lift, you must move through air, right? That is the forward motion and the forward force is called as thrust. Okay, so we have weight, lift, then we have to move forward, that is thrust, and the resistive force against it is what? What is it? Drag. Right? So these are the basic four forces acting on an airplane. Now if you take this, so all those four forces are similarly acting on this small paper plane also. Right? So this is the very simplest tool that I could tell you. Take an example to describe this phenomenon. Right? And tell me now, with your knowledge, tell me, now I know that you have researched and come here without having this fundamental knowledge, you wouldn't have applied for this, I know that. Right? But tell me, how does these planes produce lift? How do they produce lift? You were there previous time also, right? She's the winner last time, I remember her face. Yeah. Without glasses, I can't see clearly. Right. So, how do these planes produce lift? What's the secret behind that? What's the reason? Why do they produce lift? Because it has a unique shape, which we call as what? The airfoil shape, aerodynamic shape. Right? So, it has a unique shape. So, with that shape, I'm not going to describe the fundamentals of it. Even though you keep very silent, I expect you all have read about it and studied. So with that unique shape, these airplanes, they can produce lift. Right? So the glider that you are going to make today is also, should be a machine like that, which can produce lift, and you should have a mechanism to give a thrust, maybe with your arm power, or maybe with another mechanism like a catapult or anything, but there should be a mechanism to produce thrust, and also you should focus on how to mitigate the impact of drag, and also how to keep the weight as low as possible, not as low as possible, let's say at an optimum level, okay, and also produce lift, right? So coming back to this, okay, before that, now I'll again try to fly this damn thing. I don't know, it doesn't fly today. Yeah, right. So yeah, it went to the right spot. So you just check it and see. Do you feel there's some speciality in the contour of that? You just check it and tell me. Don't unfold it.
There are two pieces that might increase the drag.
Okay, so he has observed there are two kind of flaps coming outward. Yes, it adds on to the drag. Yes. So let me just correct it in this manner. Simple modifications. Okay. Right. Right. You everybody, right? This just fold it like this and see if you can. What you can feel when you just move your fingers along. What you can feel. You feel something, and is there anything triggering in your mind? Does it ring a bell? I can't take much time. Would someone here like to test it? Right. There's one guy who picked it up correctly. Okay, yes. No idea? What is it? Thickness. Okay. Center of gravity. Okay, okay. Much more advanced thinking. So in the front, it has some thickness, right? It has some thickness, and as you move along here, as you move your fingers, then it becomes thicker and thicker, right? And then again, when you come towards the tail, it reduces the thickness and becomes very thin, and this is the thinnest part. Okay. So what is it? What is it? Now, if you just look against a source of light, also you can see that, right? So here it has some sort of thickness, and in this part, this is the thickest part, again reducing, and the thinnest part. So what is it? Can I get a picture of an airfoil here? What is it? It's an airfoil. Okay, it's an airfoil. That's why it keeps flying, right? See, if it had enough height here, I would have shown you, demonstrated how efficient is that as a paper plane, right? Okay, leave it there. So everybody must get your fingers to feel how does it look like, right? So because it's an airfoil, right? So in today's exercise, so you have been given with the instructions. These are the limitations that you will have to stick to, right? There's a weight, minimum weight, and also a maximum weight. There are dimensions given to your glider, okay? So I'll take a couple of minutes to talk about the fundamental mistakes that you may make today, right? So try to get rid of that as much as possible, okay? Number one. Now, right, now this is an airfoil, right? Okay, may තියෙන ලොකු බණ්ඩියක් තියෙනවනේ මේද? Right? So I know you people will try to make an airfoil like that. Don't do that. Why? Now in this paper plane, do you know? At a glance, you can't see that there's a thickness like that. ඒ බණ්ඩි ගෙඩියක් තියෙනවා වගේ පේන්නේ නැහැ. නේද? Right? But it's a very thin airfoil, right? So don't make it thicker like this. Number one, putting in right? No, the airfoil doesn't have to be thick, right? Yes, of course, there's a thicker part, but it doesn't have to be like Badamugalari. Okay? I won't say how to make that, but keep that in mind, right? Because when you make this very thick, what happens? Then there's a phenomenon called creating boundary layers. That is just like now, if you now we talked about drag, and if we try to reduce the drag to 0 and try to fly this machine, would that machine fly if the drag is 0? No, because there has to be an interaction between air and the body, air and the airfoil. Okay. Now it's the same way. If the wheels of your vehicle has 0 friction with the ground, the vehicle won't move, right? The same phenomenon goes into here also. So remember that. And if this airfoil is going to be thicker and thicker, then you will have to propel that with the speed of the light, because to have that boundary layers interacting with this body. Okay, so keep that in mind. Number one. It has to be aesthetically appealing also, and also reduce. Now you gotta reduce drag by means of other aspects. Now for an example, can I get a CFD image of an airplane? CFD image of an airplane, right? So in this case, right, so you will see the red color spots are the highest drag creating places, right? Bluish ones are low drag places, right? Even you're gonna take this one, hey boy, right? In this case, right? So red color shows you a higher drag area, right? Why? Why is that? Because in any shape, as they move through air, there are contours, shapes that is coming out of a body, and due to the contour, it has a tendency towards increasing drag. Keep that in mind. How to reduce the drag as much as possible, right? Yes, I said should be an interaction between your wing and the air, but also at the same time your glider, the entire airplane, right? It has to, it should be, the drag should be reduced, right? So get rid of pointy, sharp edges, okay? Have you all watched that movie, Dictator? Dictator, there's a comedy movie. So in that case, how do they make that rocket? The dictator himself, General Aladdin, he says, it has to be pointy. Can you remember that? Right? Not round. Right? So don't expect the pointy edges to, penetrate through air. Don't misinterpret as the pointy sharp edges would have less drag. No, not that. Right? Not that. So keep that in mind, how to reduce drag. Okay? In general, wide wings, high wings, they have considerably higher ability of lift. But in this case, go to the assessment criteria also, right? And see how marks are given, to which areas the marks are allocated. So you should be able to demonstrate a few things, not the distance that your glider could fly. Not only that, but there are other aspects, right? We are going to test. Give your thoughts into that, and also try to make your glider capable of performing those tricks. Okay? So basically that's what I wanted to share with you, because I'm not going to give you much details. It's like, I'd be doing your project then if I'm going to give you more instructions. And I believe that this much is more than enough. And each and every team will be given a mentor, but the mentor is not supposed to be a part of the team, only a mentor. It's not your team, right? Don't get into a psyche of, oh, this is my team, I should support them to win. No, not that. I mean, just guide them how to, if they are violating the fundamentals, that team doesn't need a mentor. See, if they are violating the fundamentals, stuff like that, then you could just correct them or just give a hint like that. So that's the way that we will operate. Do you have any things to clarify before we move on? Any gray areas? Anything you want me to clarify, explain further? No. Everybody ready? Ready? Then say ready.
Ready.
Okay. All the best to you guys. So you will have 3 hours to make your glider. And also remember this one. This will dedicate this whole day to Otto Lilienthal. Who is Otto Lilienthal? Hey, you buggers, you explain. Who is Otto Lilienthal? Otto Lilienthal? Go under the desk. Otto Lilienthal, he has carried out more than 2,500 glider test flights at the age of 48. And the fascinating thing that he has done for aviation, he lived in the 19th century, that is in 1800s. He's a German scientist, Otto Lilienthal. Now, he carried out, he himself built a number of gliders and tested by himself. And he has carried out more than 2,500 test flying. And the most fascinating thing is that he has recorded all the results. All the results he had recorded, and the subsequent developments, even the developments of the Wright brothers also have been immensely influenced by this gentleman, Otto Lilienthal. Unfortunately, he succumbed to the injuries caused by a fatal glider crash that happened in 1888 or 86 or 1890s. Can't remember exactly, but unfortunately at the age of 48, right? So if he had extended, if he was fortunate enough to extend his life, sometimes he might have been the first person to fly a powered aircraft. And remember the difference between these gliders and the other aircraft. Gliders are not powered, the other planes are powered. Okay, what Wright brothers have done was the first man-made heavier than air powered flight. That's what has happened on the 17th of December 1903 at Kitty Hawk, Carolina. Right, anyway, now let's dedicate this whole day, whole exercise to the name of that great scientist, the great innovator, Otto Lilienthal. Okay guys, all the best to you. You start work. If there's any further instructions, she will give that. So we'll take 3 hours to, we'll allow you to have 3 hours to produce your glider and we'll test flight it. Okay, all the best. Good luck.